Alrighty, guys. Many of you did pretty well yesterday with simplifying the radicals when the numbers inside the radical were not perfect squares. Maybe it's not as hard as I thought it was, or maybe I just taught it so well that you had no choice but to just get it. Today we're going to move on to some radicals that have variables inside. Sounds scarier, believe it or not, it's actually easier. The variables are easier to do than the numbers are. It's a simple rule. So when the radical and the radicand is an expression with numbers and variables, you're going to simplify each one separately. So these will have numbers and variables inside. You'll do the number by itself, you'll simplify that, and then you'll take the variable and you'll simplify that. So simplify the number like you did before. Simplify the variables using the fact that the square root of a variable is half of the exponent. Used to the exponent divided by 2. So the square root of x squared is just x to the first power. Square root of x to the 10th power be x to the 5th power. Square root of x to the 24th power be x to the 12th power. You're just taking the exponent divided by 2. Variable has an even exponent, it's a perfect square. And it's going to completely come out of the radical just by dividing by 2. The only difficulty comes is when the exponent on the variable is odd. It's really not tough, but if the exponent on the variable is odd, you're going to break it down into 2 separate pieces, using the multiplication and division rule of exponents. You're going to factor it into an even exponent that's 1 less than whatever that odd exponent is. And then the first power would be the second term. And then what you do is you'll remove the even exponent, because that's a perfect square, and that variable to the first power, a power of 1, will always remain inside the radical. Probably sounds a lot more complicated than it really is. So I have a couple of examples for you. It's really not that bad. If you understood yesterday, today is probably going to be even easier. So let's take a look at this. Square root of 50f squared. Well, let's take that 50 first. The 50 is 25 times 2. Breaking it down using the fact that 25 is a perfect square factor of 50. 25 times 2, and then f squared. So the 25 will come out of the radical because that's our perfect square, and that becomes a coefficient of 5. Inside the radical remains the not perfect square factor, which is 2. Notice I left some space here. That was not by accident. F squared is a perfect square because the exponent to f squared is an even number. So I just take that exponent and divide it by 2 and bring it out of the radical also. So f squared comes out of the radical and becomes f to the first power, or just f. And there are no f's left inside because the f squared was a perfect square the same way 25 was. And there's my answer. Ta-da! 12p to the 4th power. 12 not a perfect square, but 12 has a perfect square factor. That's a pretty easy one. That's 4 times 3. And then times the p to the 4th power. So this 4 is a perfect square that comes out and becomes a coefficient of 2. I'm going to leave a little space there because I know something else is going to come out with my variable. The 3 remains inside the radical. P to the 4th power has an even exponent. It's a 4th power. So it's a perfect square. I'll take it out by dividing the exponent by 2. Square root of 4's divided by 2 gives me an exponent of 2. So 2p squared is on the outside times the square root of 3 on the inside. Ta-da! Variable's really not tough. They're actually easier than the numbers. Got a couple of odd exponents for you here. First, let's break down 125. 125 has a perfect square factor, and that perfect square factor is 25. That's 25 times 5 times. V to the 9th has an odd exponent, not a perfect square. So I'm going to break that down into 1 less than that, which will give me an even number, v to the 8th power. It's just this exponent odd minus 1 times v to the 1st power. Because you know that when you multiply, these exponents get added, so 8th power and 1st power makes 9th power. And now I remove my perfect squares. 25 is a perfect square. That comes out to become a 5. V to the 8th power is a perfect square. Take the exponent, divide it by 2, That gives me v to the 4th power. Remaining inside the radical, the factors that are not perfect squares, 5 and v. Ta-da. Anytime you have an exponent on the inside of the radical on a variable that's odd, you'll always end up with a 1 first power left inside, and the rest of them come out because they'll become the perfect square. There's a coefficient already, so that's going to have to multiply. So it's 6 times square root of, let's break that 12 down into 4 times 3. And the v to the 7th power, or sorry, z to the 7th power, I'm going to break that into z to the even exponent below it, 6th power, times z to the 1st power. It's always going to be 1 less than that, and then 1. That's how we get 7, or whatever this number is. 1 less than that plus 1 makes it again. All right, let's bring out what we're bringing out. The 6 is out there. This 4 is coming out and becoming a 2 when I do the square root. So I had a 6. I'm bringing out a 2. Remember, this is a multiplication, so they'll multiply. So now my number coefficient is 12. Z to the 6th, this is my perfect square because the exponent's even. Divide that by 2. Z cubed. And left inside the radical is the imperfect square factor 3. And then the first power of the variable, z. Like I said, if you got it yesterday with the numbers, the variables don't add anything tougher. They're pretty easy. Last couple have 2 variables. So just do 1 variable at a time. Square root of 40. Let's see, that's 4 times 10. By the way, look how nice and straight that line is. That's drawn with a mouse. I'm proud of myself. Gotta do something to keep myself occupied. U to the 3rd power is odd, so I'm going to break that down into u squared times u to the 1st. And v to the 8th power is even, so I don't need to break it down. I'm going to leave it as v to the 8th power because it's already a perfect square. So now take those perfect squares and bring them out. 4 is a perfect square. That becomes a 2. Even exponent divides by 2, so u to the 2nd power becomes u to the 1st, or just u. V to the 8th power has an even exponent, comes out, divided by 2. V to the 4th power. And left inside is the 10, which everybody tries to simplify and is not simplifiable because there are no perfect square factors. That u to the 1st power. And no v's because v was an even exponent, so that's a perfect square and all the v's came out of the radical. Final answer. And last but not least, 9 is my coefficient on the outside. Keep it out there where it is. Square root of, let's see, 245. I think we dealt with 245 yesterday, if I'm not mistaken. 245 has a perfect square factor that many people don't know about. That perfect square factor is 49. It's 49 times 5. If you didn't know that 49 was a perfect square factor, you could have tried dividing by 5 since it ended at 5 to see what it gave you as the other factor pair, and it turned out that was your perfect square. Y to the 9th is an odd exponent, so I'm going to break that down into y to the 8th with an even exponent, so it's a perfect square, and y to the 1st. And z to the 4th is already an even exponent, already a perfect square. Don't need to change it. I'm just going to bring it out. All right, let's bring out what comes out. Perfect square of 49 comes out and becomes a 7. 9's already there. That makes it a 63. Y to the 8th, perfect square because it's even. Bring it out, divide the exponent by 2. Y to the 4th. Z to the 4th, divide the exponent by 2. Z squared. And left inside the radical, that imperfect square 5 and the y. You know you're going to have just a y left inside because the y had the odd exponent. The z had the even exponent. It's going to be a perfect square. It's going to completely remove itself from the radical because it's a perfect square. That's how it works. Not too tough, just a little more practice, and now you got some variables to deal with too. But the variables, they don't really add that much of a challenge. Sometimes the numbers are a lot more challenging than the variables. All right, giddy up.